Hi friends, very good morning. This is Dr. G. Srinivasa Gupta, Professor from Department of Mechanical Engineering of VJEC Institute of Engineering Technology. As a part of Dynamics of Mystery course, today we are going to see more elaborated way of free undamped vibrations. As we have seen previously, what are vibrations? So it is simple oscillatory motion of a body about its equilibrium position. When body is disturbed from just rest position, then it tends to move back and forth due to restoring force. The disturbance given is against elastic constraint forces. Body is trying to restore back to its equilibrium position. So there are external disturbance, that force, and restoring force. These are the forces. This motion repeats periodically if there is no external or frictional resistance against the motion. As we have seen in the model, we take the object or body which is oscillating, having some mass and some elastic property, and if external resistance or frictional resistance is there, we will consider some damping element. Okay, so some terminology also we have seen. And types of mechanical vibrations we have seen based on excitation, based on energy dissipation, based on linearity, and based on motion, based on system characteristics. So we have seen so and so forth. So concept of vibration and the basic equation of motion we have seen. This is basically a sinusoidal equation that let us discuss today the equation of motion of free undamped vibrations more elaborately. We have seen just the mass, it has some spring having some mass is attached. Before attaching the mass, the spring is at this position, let us say position A. Then if you attach the mass to the spring, that is not only elastic property, it has some object has some mass. Then it is going to displace, because of attaching the mass, some amount of displacement is there. Okay, then mass is attached, then it is A position. Now if you attach, then it will reach some elongate and reach some position. These are longitudinal along the axis of the spring, we can say longitudinal direction. Then the position which is changed because of attach of mass is some delta, let us say. Then it is maintaining equilibrium, no motion. Once you mass attach, it comes under equilibrium. Okay, then static position. This is called static deflection. Then if you take this mass and draw free body diagram, then what is this? This is mg is the downward force on this mass, and upward because of spring has some stiffness coefficient, that is K we defined earlier also we have seen. Then this restoring force acting on the or reaction acting on the mass is K delta. Okay, so we can write simply from the equilibrium equation this mg equal to K delta. Okay, in this equilibrium position. Then we can write this K by m equal to G by delta. This is static deflection. So as you have seen the equation, basic equation of free undamped vibrations. Okay, if you displace it, keep it equation aside. If you displace it further, some extra displacement down, then it is going to start oscillations down and up, down and up. Then in that case you have given x displacement downward and disturbed and leave it. Then what happened because of this? Because it will oscillate, and you can see some acceleration, velocity and acceleration due to this x. You can write the velocity component x dash, x dot, and the acceleration component is x double dot. Then if you draw free body diagram, this acceleration force downward mx dot, but the inertia force is upward. You can show minus mx dot. And we have seen that is mx. If you say mx dot is this one, upward direction if you show, you need not write minus as it. Okay, then what are the other forces on this? This is restoring force or reaction on the mass, then you can say it is kx. The x displacement is given. This is acceleration force. Inertia force is this one. So then, based on D'Alembert principle, we have seen the inertia forces and the external forces or reactions on the body must be sum of algebraic sum must be 0. Based on that, we can write this as equation is mx double dot inertia force plus kx equal to 0. Okay, this is based on D'Alembert's principle, or you can use Newton's law, or you can use energy method. You can kinetic energy and potential energy. Okay, so any approach will give same equation. Then this equation further you can write. This is x double dot into k by m into x equal to 0. This is in the form of, this is second order differential equation, but it is the basically sinusoidal equation which can be taken in the form we can write, because it is oscillating. We can say this is omega n square x. Why we are writing omega n square is we have defined this one omega n square is k by m, right? So we have seen omega n you want here, omega n, then omega n is root k over m. Here from this you can see we can substitute root k over m is also root g by delta. If you know static deflection, then this can be written as root square root g over delta. This means it is natural frequency of the system. Okay, natural frequency, that's why we are using n. This is units are radians per second. Okay, it is clear, I think. The solution of which is in the form I have written here, xt. X is function of time period, a cos omega nt plus b sin omega nt. So this is the solution where a and b are constants which can be evaluated from integration of this equation by substituting initial conditions. Okay, so I think you are able to understand, because this is sinusoidal equation. This is the solution may be in the form based on the fundamentals of mathematics. Okay, by making proper substitution of forms of this solution can be written as, okay, suppose this is a cos omega nt, b sin omega nt. So I will write this x is function of time, a cos omega nt plus b sin omega nt. This is the form. Then this a and b are the integration constants which can be evaluated by substituting initial conditions, whatever you are going to apply, the way you displace. And also you can suppose, for example, you can say a is taken in the expression form x cos pi, okay, and b is taken in the form of x sin pi, because this is also simple harmonic motion where x is maximum amplitude, okay, maximum displacement you can say. Then if you use this, then you can substitute x. Let us take this and you can understand why we have taken. Of course, these are also function of some pi, okay, phase angle. So as you know that simple harmonic motion, how it can be taken. Then if you substitute this, then you will get cos omega nt cos pi, x you take common, then cos pi plus sin omega nt. It is solution is in the form what we have written, sin, okay, a cos omega nt and sin omega nt. Then okay, right. Then if you write here also b sin b x is taken sin omega nt sin pi. Then what is this in the simplified form? X equal to x. Okay, what is cos omega nt cos pi and sin omega nt sin pi? It is going to give, okay, cos omega nt minus pi. Okay, this is also another form of the solution is in the another form. Also, if you can substitute the values like this in this equation, you can also take not only x cos pi, x sin pi. You can also adapt also another way is A is take A is okay x sin pi sin psi, another, let us say another form, and B is x cos psi, let us say. If you substitute these, then see that in the equation x equal to, you can have okay x cos sin pi sin psi cos omega nt plus cos psi sin omega nt. What is this? This is, you can write, this equation is x sin omega nt plus psi. So this is in the form. This is also, you can, it may have, you can express in different forms. We have seen that omega n is, where omega n is square root of k by m. This is radians per second. As you know that per one cycle of motion completed in 2 pi radians. One cycle I told already, if it is a motion is like this, x and time period, then one cycle is repetition of this from year to year. This is one cycle. It will take 2 pi radians. Then if you want time required for each cycle, then you can write, because this is radians per second, time required for each cycle you can write t pi by omega n. Then 2 pi by, you can write 2 pi into square root of m by k, 1 by omega n, m by k, you can write. And also natural, this omega n is called circular linear frequency, and natural, okay, circular natural frequency omega n, and if you want linear natural frequency, that is vibration, it is circular natural frequency, it is called linear natural frequency 1, you can write 1 by t. 1 by t is, you know that, 1 by 2 pi, okay, that is into, okay, 1 by t. So 1 by 2 pi by means you will get root over, that is k by m, that is omega n by 2 pi. Omega n by 2 pi is linear natural frequency, you can call. In general, we will say natural frequency. Based on units we are using, year units, because this is radians per second, time period, okay, time required for each cycle, you can say. This is 2 pi, this is cycles per second. How many cycles required per second? Okay, this is called Hz. Okay, in this way we can, based on units, you can use this linear natural frequency or circular natural frequency as you wish. Okay, so I think you are able to understand. Different forms of this equation can be written, whether x equal to x maximum amplitude, this is, I will further elaborate, cos omega nt minus pi, or x sin omega nt plus psi, x, this is generally amplitude at any okay time or phase angle, right? Understand or not? So now coming to the further elaboration of this, suppose for example, if you are giving the disturbance, okay, displacing a mass through a distance x naught, you are displacing this mass, okay, spring and mass through a x naught distance, x naught, and also giving a velocity v naught. This is initial, at time equal 0, you are giving x is, displacement is x equal to x naught, initial, it is called initial condition, and velocity is v naught. Then you can use these values in the equation. That is, what is our equation? I will take a sin omega nt plus b cos omega nt. You can, let me take this, and if you use these values, what is t? Time is 0, x becomes, at the time period t equal to 0 initially, x becomes x naught, and x dot becomes v naught, let us say, initial velocity you are given while, okay, displacing the mass. Then the constants a and b can be, by substituting this, you can say x equal to a sin omega nt, what is it? Because t is 0, then it is 0, plus b cos omega nt, t is 0, so this cos omega nt become 1. So this is initial, means x naught, because you are substituting initial t, then x is x naught. Then because a into 0, 0, b. So b you are going to get, b is your x naught. Okay, further differentiate this equation. X dot equal to a omega n cos omega n t. Differentiate with respect to derivative of this, okay, time derivative, let us say. Then x dot velocity, it becomes, okay, a omega n cos omega n t plus b omega n sin omega n t, because derivative of cos omega n t is minus sin omega n t, minus sin you will get. Now v naught means initial time, that is at starting t is 0, then velocity is v naught, as we have used that v naught is our initial velocity. Then it becomes a omega n cos omega n t, t is 0 becomes 1 plus minus b omega n sin omega n t becomes 0. Okay, so from this you can see that v naught by omega n is your a. Okay, a is v naught by omega n, b is x naught. So you can write equation. A is omega v naught by omega n sin omega n t plus, okay, t plus b is your b is x naught, okay, cos omega n t. So it's clear that this is another form. If you initial velocity you have given is, okay, v naught and displacement is x naught, then the solution graphically also you can represent this solution. You have seen that, okay, your okay, x, a and b values. Suppose it is mean position, it is displacing, then it is your x, okay, this is x naught initially given, and let us say this x is v naught by omega n. Then what is maximum, that is x is this, okay, here in this equation wherever we have written x maximum displacement, that is this is, you will get x equal to, okay, under square root square x naught square plus v naught by omega n square. Is it or not? So this you want to see in the graphical form. This is initially, okay, initially you have given x naught, because this is your x naught, okay, then you can see this in the graphical form as, so this is your displacement x y coordinate, this is your time, okay. So you can see that you will have this displacement as, okay, like you will have, okay, because this must be coincident, this is maximum and here also this is the maximum, okay, we will have this displacement like this. Okay, one cycle means this is starting here and again it is going to end here. This is becomes one cycle, okay, starting and ending. Okay, are you able to understand? So this is 2 pi, one cycle, right? Okay, so you will have maximum is under square root of x naught square plus v naught by omega n square. Initial displacement x naught and velocity v naught if you give. Okay, suppose another form also you can take. Suppose x equal to x sin omega n t plus pi, as we have seen. Yes, if you take this equation, let us say, then x dot you will have x cos omega n t plus pi, sorry, you have to write in this bracket, omega n t plus phi, okay, and into omega n. Okay, so initial values if you want to substitute, then x dot e becomes v naught, okay, v naught equal to your x cos omega, okay, if you substitute initial means v naught means t is 0, then you will have x cos pi into omega n. Are you able to understand? Then you are going to get here v naught by omega n equal to x cos pi. Is it clear? Then similarly, if you substitute displacement here in this, okay, initial displacement x naught, okay, at time period t, then you will have sin pi. So, okay, x naught equal to x sin pi, v naught equal to, v naught by omega n equal to x cos pi. Okay, if you square both these and add these, then obviously from these two, you will get x equal to square root of x naught square plus v naught by omega n square. So, whatever initial form you are going to take, but okay, your displacement initially some certain values x naught and v naught, then this maximum amplitude is same, it won't change. Okay, then the pi you want, then you can write tan pi is phase angle, is your tan pi is okay x naught, because x naught is this component, x naught by omega, v naught by omega n, okay, x naught omega n by v naught, or pi is tan inverse, you can write pi is tan inverse x naught omega n by v naught. Okay, you can also take the equation initial begin with this one, instead of x equal to x sin omega n t plus pi, you have also seen x equal to, you can take x cos, you have seen previously the equation, what is that, you have seen minus with minus this one, cos omega n t minus pi. Okay, you can also take that cos omega n another form minus pi. Okay, minus pi or minus I, whatever. Okay, this form also you can take, you can use initial values and substitute, you can get same maximum amplitude, you can verify. And also one more thing is, you can take initial conditions different in the sense, you can take, you have disturbed with initial velocity x equal to x naught, initial velocity at time period t equal to 0, your initial velocity is equal to x naught, and you have just leave that one with displacing and leaving, then velocity, there is no velocity is 0, then use these values and same equation you take and substitute, and again different derivative of this general displacement equation and substitute initial conditions, your v is 0 initially, then you simplify, you are going to get similar expression. For my amplitude is always same. Okay, you can see the verify and do that one also. So in this way we can initial solution in different forms we can adapt. I am talking about only undamped free vibrations for today's our discussion. Okay, so this is the different forms of equation, and you can also plot accordingly. That here in this free undamped vibrations we have seen that plot is made. Okay, and this is equation, this is the equation for this sinusoidal variation is x equal to equation we have seen in different forms, x equal to a sin omega n t plus b cos omega n t 1, or we can have different, we have seen x equal to x sin omega n t plus psi we have used, or we can say this x equal to x cos omega n t minus pi. Okay, all are representing same curve equation. And maximum amplitude x is maximum amplitude, that is for all these you will have x naught square plus v naught by omega n whole square. This is the maximum amplitude if you have initial values. Suppose initially you disturbed with x naught and there is no velocity, initial velocity, then it is x equal becomes x naught. Okay, initially, that is okay, initial disturbance x equal to x naught. So in this way you can interpret different ways of this undamped free vibrations equation. It is simply a sinusoidal equation. The solution for this, that's why the solution for this can be written in this form, and you can solve for a and b, the integration constants, by substituting initial values in this way. With this I am going to conclude this lecture here. We will see more about second case, that is damped free vibrations, in our next session. Thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.